Okay, let's take care of video number 76. We're doing assignment number 31. I'm sorry, the last video should have been video number 75. I sent a little note there. Whatever, have to fix that up. I don't know how to edit these things, so it doesn't matter all that much. Okay, so as promised, we're going to go over all these three problems and make sure that we've done them twice, much as we would do in class. And the first one has been explained to you, but I'll do it again anyway. I'll move over the camera, and it says subtract k minus k cubed plus 2k squared from. So again, you were taught to what you're taking from, to write that out. I'll go sideways, and this time, since I'm doing it a different time a different way each time, there we go, subtracting this from this, okay? And I didn't bother to put it into standard form. I can do that now. This would be minus 2k cubed plus 2k squared plus 1. And then we take the opposite, has been explained to you, so we'll go in order here. So the negative of a negative is plus k third to the third minus k squared minus k. Okay? So we go over it again to make sure we haven't committed a mistake. And the opposite of the highest degree to the third is a positive. The opposite to the second one is a negative. And the opposite to the third one in order of degree is a negative. And now we just put everybody together. This and this becomes this. This and this disappears. And then comes your negative k. And finally, positive 1 going in order. And again, I never resist putting the temptation to put that there, just so you can see what's really going on. Okay, so this is a cubic trinomial. Nobody asked you that. That's the math. That's the thing that they want you to do. So I guess we can put some more in, but with the video we had this morning of multiplication, this kind of math comes up naturally, so you'll have to use it to get different answers, so to speak. Okay, so now we look at number 2, and it says, what do you add? So there's the what. And do you add 2? And I'll put it in standard form. Like I said, I'm doing it different ways. There's the squared again. Always leave that out. I don't know why. And there we go. And there's the minus 3 to get. And again, there's the, to get this minus x squared minus 4x plus 1. It seems more convenient to do this laterally, horizontally, but you certainly don't have to do that. This part's been explained a number of times. What you do on one side, you do on the other side. And there's a squared again, always leaving it out, isn't that amazing? Plus 3, and so you see that subtraction is just taking the opposite. It's not like you'd imagine with numbers, and n's and p's rule the roost here. And there we go with our missing answer. And you can check that easily on your own by adding this to get that. Okay? As I did the other day. So there we go. I did these two problems twice, and I dedicated time to having you do them, and so you're expected to do this. And we're merging, like I said, for this first video, we're going away little by little from addition and subtraction to multiplication. So you'll see lots of this stuff when you multiply as well. So now I focus on the third problem, and we want to find the restrictions and the possible W's, and then the possible perimeters. So here we go again. I line up the sides, okay? And I'm doing this just to help you because this is the kind of math you'll be doing down the road, this level of sophistication. And all of these guys, we agree, have to be 0, otherwise this figure doesn't exist. I've said that a number of times. So to say that 2w is greater than 0, everyone is greater than 0, then maybe an implication button, I don't know, is greater than -4, so that means w must be greater than -2, but that's a minor thing. To say that 3w minus 6 is greater than 0 is to say that 3w is greater than 6, which is saying that w must be greater than 2. So we care about that side. That side is going to give us an important restriction here. Because what good does it pick w as -2 when it doesn't work here, when the another w must be greater than 2? And here we go, a little bit of Common Core math, and there we go. So 10 must be greater than 5. So if I divide both sides by 2, that means that 5 must be greater than w, or just saying it the other way around, w is less than 5. And here we don't waste much time. W must be greater than -2, but we had that twice coming up. So here we go with our two basic conditions, our two basic restrictions. W is greater than 2, and w is less than 5. So the solution set is 3 and 4 only, okay? And the perimeters, when we add them all up together, excuse me for taking a shortcut here. I took care of the w's here. So there's 4w, and let's add these up. Let's see, not to make a mistake, you know how careless I am. 4 plus 10 is 14, plus 6 is 16. So look, these guys all cancel, so it's 4w plus 10. So that means it's 4 times 3 plus 10, and 4 times 4 plus 10, or only the two possible perimeters of this object, 22 and 26. The w's can only be 3 and 4. I hope that helped a little bit. We'll come back to these ideas anyway. They're certainly not going away. Okay, so I did assignment number 31. I mentioned I'm going to send you an assignment based on what I did this morning, and we're making progress on our day.